Hello and welcome back. In the last video we spoke about a project that I'm embarking on to try and resurrect Boots homebrew beer yeast using a sachet of dried yeast from around about the 80s or 90s. And if you want to know more about that, I'm going to leave the link in the description down below. But in this episode we're going to start to look at some of the equipment and techniques that we're going to be using in that project. So first off, some terminology. Most of us are familiar with the terms clean, sanitize and sterilize. And in the brewing world, they're often used interchangeably, but they have subtle and important differences. Cleaning is about removing the physical grime from our equipment. That might have a tainting effect on our beer itself, but it might also harbour microorganisms that could grow in our beer and produce off flavours. So when we clean our equipment, we're removing that grime, but that doesn't necessarily mean that we remove all of the microorganisms. When we sanitize our equipment, we remove as many of those microorganisms as possible, but we don't reduce them to zero, we just reduce them to the point that they have a negligible effect on our beer, and they can't outcompete our yeast that we introduce into the beer ourselves. Sterilising, on the other hand, is about getting rid of 100% of those microorganisms that we don't want. Now, when we are growing yeast from single cells, as we're going to be, if you have individual cells of bacteria or wild yeast on your petri dish, that is going to have just as much of a chance of growing as the yeast that we actually want to grow. So it's important that we sterilise our equipment and our media so that there are no wild yeasts, no bacteria, and it's perfectly ready for us to put our yeast on and grow that. So there are a few different ways of sterilising equipment. First is dry heat. Now you can do this with an oven at home. The problem with dry heat is that it needs quite high temperatures and quite long periods of time to actually sterilise your equipment. And that's because the air within the oven is quite a poor conductor of heat. You can use chemicals, but the residues of those chemicals can also kill whatever it is that you want to grow on the petri dish, for example. So it's important to remove that, but at the same time you don't want to contaminate the dish when you're cleaning off your sterilising. So the other option is incineration, passing something through a flame, but that's completely impractical when you're working with glassware. You don't really want to get your glass up to red hot temperatures. So that's where wet heat comes in, and using something like an autoclave. This works at high pressures, but fairly high temperatures, about 121 degrees Celsius, and produces steam. That steam is a good conductor of energy, and it means that we can use relatively short periods of time at relatively low temperatures to sterilise our equipment. This autoclave here is an SES 2000. I think it's quite an early one. Judging by the serial numbers on the machine on the different parts, I think it's from around about the late 80s. We got it for about 150 quid off of eBay. And annoyingly, this early model is slightly different to the one that the manuals are available for online. This has a manual fill valve on it. The newer models that are far more common have an automatic fill on them. So I'm going to talk about a bit about this machine so that if you find one of these, you can use it yourself, you know what the different bits do. But we'll also have a general overview of what an autoclave is. So first off, we've got the chamber. Now this is a pressure vessel. We've got a heating element in the bottom to get the water up to temperature, create steam, create pressure. We've got various valves for allowing water in and steam out. We've got thermocouples for keeping track of the temperature for safety and for just keeping the temperature that we want within the vessel. And we also have a safety pressure release valve at the back, so that if this gets to too high a temperature, it releases that steam and gives us a safe environment again. At the front, we've got the door. So this turns to lock in place on these posts here. and that allows us to get into the pressure vessel, but also allows us to get those high pressures and high temperatures. We've also got a little safety switch here which detects when the door is locked, and there's a little plunger here which is activated by the pressure in the chamber itself, and that will lock the door so that you cannot open it while there is pressure within the vessel. That keeps us safe. At the top we have a reservoir. We put distilled water in here. We don't want to put tap water in there because the dissolved solids will come out in this high temperature, high pressure environment and might potentially damage this machine. On the control panel of the autoclave, we've got buttons for selecting the cycle that we want to use, both 121 and 134 degrees Celsius with and without drying. We've got a temperature gauge which will show us the temperature inside of the chamber and will also tell us what part of the cycle we're on. There is a pressure gauge to show us the pressure within the chamber, and then we've got a power switch, an overheat indicator, and we have the valve for allowing water from the reservoir into the chamber. First off, we want to fill our vessel, so we want to add some water into here that we can convert into steam. On this model we have to do that manually. On the side here we have a valve for allowing water into the vessel, and inside we have a little hole in the mesh that covers the heating element, and what we want to do is open this valve and allow enough water in that it reaches that little hole, and then we can shut that valve off and isolate the pressure vessel here from the reservoir. Now that is the main difference between this version of the SES 2000 and the other versions that are available. So you can use the manual for most of this machine, most of this version. Now we've got the items that we want to put into the autoclave. We've got this stand here with some little tiny vessels in. Now we're going to leave the lids on these slightly open. That is because we're going to be building up high pressures inside of the autoclave, and we don't want that damaging these vessels. We're also going to put onto these little containers some of this. Now this looks like masking tape. It's actually autoclave tape, and this changes colour when it has been exposed to the relevant heat and moisture to sterilise. So we're going to put a little bit onto each of these containers, and once we've finished our sterilisation we're going to leave that on so that we can tell in the future that these have been sterilised. Now we're going to put our items into the autoclave. I'm going to close the door, lock it, and turn the machine on. So once the cycle's finished, the autoclave will let out the pressure, and you might have seen a lot of steam coming out of the machine. It's not supposed to do that. There's meant to be a cover on the reservoir up here, but unfortunately this machine didn't come with that, and the one that I've ordered hasn't turned up yet. Once it's released the pressure, it will go into a drying cycle to evaporate any condensed water on the inside of the chamber, and then once that's finished, it will show finished on here and it will beep to let you know. So at this point we can now open the door, unlock it and open it. And you'll notice that everything inside is still very hot, so you want to be careful removing anything from the autoclave at this point. Now if I take out the items that we've been sterilising, you'll notice that the autoclave tape on the vessels has now got black stripes on it. So that tells us that these have been sterilised. So that's the autoclave. Now, you don't have to use an autoclave. This is, after all, just a glorified pressure cooker with some automatic bits on it. You can use a pressure cooker. You just have to make sure that it's large enough to fit what you want to sterilise inside of it. And of course, you generally set the pressure on those rather than the temperature. The pressure is correlated to the temperature, and you can find conversions for that online. And the other disadvantage to those is you do normally heat them with gas. So if you want to use electricity, then maybe look at an autoclave. Autoclaves come in different shapes and sizes. They cost different amounts. This one was relatively cheap. You can get a brand new autoclave for about the same price as this from China through the usual eBay and AliExpress and what have you. And those ones are upright rather than the chamber being on its side, so they fit taller things, which can be good for things like conical flasks. The disadvantage of those is that they have no timing equipment within them, and again they are holding a pressure rather than holding a temperature. You also won't have the certification that a proper autoclave bought through a reputable company will have. That said, some other YouTubers who know a lot more about this stuff than me do use those Chinese autoclaves. At this point, I'd like to mention a couple of YouTube channels I've found extremely useful with this project. The first is the Thought Emporium. That guy is amazing. He has videos on how to set up your own DIY biology lab, and has all sorts of videos from glow-in-the-dark yeast to trying to cure his own lactose intolerance using gene modification. So the other YouTube channel that I would like to recommend is Sui Generis Brewing. He has plenty of videos on growing yeast up from individual cells and all of the sorts of stuff that I will be doing. So if you're interested in this sort of work, make sure to check out his channel too. They're both in the description down below. Next time, we're going to be making plates and slants for growing and storing our yeast. Thank you very much for watching, and I'll see you next time.